In the United States alone, enough usable wood is wasted to build approximately 65,000 single-family homes. The United States culture typically relegates timber to use only in small-scale residential projects. However, new opportunities to explore the application of timber-formed architecture arise from the increasingly complex needs of our society. Usable timber is often discarded because it does not meet dimensional needs for typical construction methodologies. Instead of following the current paradigm of standardized building, software and computation can allow the exploration of complex architectural systems using what is typically considered scrap material. Genetic algorithms provide the basic framework in which the system in this thesis is developed. For the system to be successful, computational processes must be used to account for the varying dimensions of scrap lumber. The software must first understand the form that is to be achieved, and then calculate a placement solution. Specifically, the system must interpret incoming data from the material and make a decision either the member is to be placed or set aside for later use. The algorithm operates on a loop until the desired form is achieved. The most basic purpose of these prototypes was to find differentiating space by organizing pieces of wood into a performative architectural element. Finding the proper pattern is the most important factor in developing complex space. A recurring theme of additive fabrication began to emerge through these studies. My initial prototypic attempts involved block stacking techniques. I set parameters of block placement to achieve a 3-foot by 3-foot panel. It quickly became evident that without a connection, these prototypes cannot be pushed towards complex forms. While initially exploring connectivity, I tested wood glue and its tolerances to achieve various organization patterns. These initial tests revealed significant limitations of glue for achieving various stacking patterns. For example, the dry time for glue necessitates holding the forms in place for long periods of time. Additionally, it was difficult to create heterogeneous spaces due to the lack of predefined form. Without any formal goals, the prototypes became aimless and did not warrant further exploration. When approaching the prototype sets, it is important to remember the process is recursive. Thinking back to the first prototypes, the goal was to accomplish a predefined form, yet the form was not understood before being attempted. If a form is contoured, the shapes of each contour can be achieved, and thus creating a complex structure. A complex system of organization and connectivity is demonstrated through the chair prototype, as a rotational alignment changes from layer to layer. Each layer connects to the previous by sufficient surface area overlap. Multiple fasteners are then positioned at each intersection between the layers to prevent rotation at the connection points. To push the potential of complexity within the system, unlocking structural geometries can provide a basis to generate forms. The idea behind pursuing columns was to help mitigate the density of material being used. Instead of trying to achieve a mass, a network of columns can create spatial conditions. Finding a suitable construction technique for the later prototypes proved to be challenging. At a very small scale, printing contour lines on paper was successful. However, once scaled up, that strategy becomes obsolete. The primary method of construction for the builds used a projection system. The images of contour lines taken from forms were projected onto a wall, and wood blocks were then placed to fit those lines. Although it proved to be a sufficient solution at the time, it was not without issues. As the build moved away from the wall, the accuracy of the contour lines became skewed, altering the shape of the structure. In addition, using the projector does not take into account the variation in wood size when determining placement, which is still decided by the builder. Currently, with the help of an engineer, a laser pointing system is in development. The software will take input lengths of the wood pieces, calculate, and point the placement of the member. Eventually, multiple lasers can be programmed. With this system, accuracy is greatly improved, and the system will become deployable in real-world scenarios.
National Weather Service has issued a tornado warning.
Woodward has been hit by a serious tornado.
How are the houses and the buildings?
Destroyed.
FEMA and the Army Corps of Engineers have very specific guidelines for emergency disaster response. Unfortunately, the transitional phases after a disaster are often overlooked. FEMA does sometimes provide trailers, but they are not guaranteed to all who need them. Furthermore, there is worry that the trailers provided by FEMA are unsafe owing to the dangerous levels of formaldehyde used in the production process. The software and systems that have been developed can be used to create transitional housing for disaster victims. With the ability to collect building resources on site, construction can begin almost immediately following a disaster event. An L system is a parallel rewriting system, or a variant of formal grammar traditionally used to model the growth processes of plant development. Architecturally, the branching is an organizational tool that allows for differentiating explorations of space. Branching occurs at several scales, initially finding a location, then setting up primary structure, and determining the interior variations. The branching system sets up the anchor points to create a network of catenary vaults. A combination of 3 and 4 anchor point vaults are used to achieve the best coverage of points. Using parametric modeling, the physical characteristics of the arches are adjusted to meet the needs of local conditions. The catenaries create a network of columns, which was the goal when performing the corbel column prototypes. On the interior of the structure, catenaries are used to create undulations in the ground plane. The variation in that plane sets up space for programmatic functions, sleeping, bathing, eating, and whatever the occupants require.